All right, let's look at number 9 and 10 from the review packet for Unit 2. So this is one of those, both of them are matching statements with reasons. So I've got the reasons handout here that we'll reference every now and then. So let me probably could have done this beforehand, huh? All right. There we go. Okay, so let's take a look. A lot of times it helps to reference the diagram, but sometimes you can do these without even having to look at it. But the first one is definitely one that I think it's easier to just look at the diagram. Here's 3, here's 6, and 3 is congruent to 6 because, well, they're vertical angles. So the reason here is vertical angles are congruent. Okay. B says if 6 is congruent to 4, then TA is perpendicular to BR. Okay, so if congruent angles, then perpendicular lines. So let's come over to our reasons. All the perpendicular stuff is on page 3 here. So let's see. This one started out with if congruent, then perpendicular. Whoops. All right. So here's one that says if congruent, then perpendicular. And it says 2 lines that form congruent adjacent angles give you perpendicular lines. So really we should just go back and make sure that it follows this pattern. 2 lines that form congruent adjacent angles. Well, yeah, we got 2 lines and they form congruent angles that are also next to each other. So they give us perpendicular lines. So this one is 2 lines form congruent adjacent angles. So you get perpendicular lines. Let me shrink that down just a little bit because that's pretty big. Oop. There. Okay, the next one, let's see. If the 2 lines are perpendicular, then angle 3 is congruent to angle 4. That's kind of like B, but flipped around. It's actually like the converse of B. If we come over to our reasons, you'll notice that 12 and 13 are actually flipped versions of each other. If you have perpendicular, then you have congruent angles. So, congruent adjacent angles. That's what this says. So that's actually our reason here. Perpendicular lines lead to congruent adjacent angles. Okay, so then the next one, if BA is perpendicular to RA, so if this one is perpendicular to this one, then the big angle is 90. Okay, well, if we come up here, if 2 lines are perpendicular, then you get 90-degree angles. Right? That's what this says. If 2 lines are perpendicular, then you get 90-degree angles. Well, that's definition of perpendicular lines. Definition. Ugh, this pen, it keeps sticking. Definition of perpendicular lines. Okay, let's see. Next one says, if this is perpendicular to this, RT, then angles 7 and 8 are complementary. So if we come back over here to our reasons, this says, if perpendicular, then you get one 90-degree angle, so that's not the same. This says, if perpendicular, then you get congruent angles, so that's not the same. This one says, if perpendicular, then you get complementary angles. That's what we want. So that's this thing. If the exterior sides are perpendicular of 2 adjacent angles, then the angles inside are going to be complements. If you look at the picture, that's exactly what we have. If these are perpendicular, then the 2 angles inside will be complements. So if the exterior sides of 2 adjacent angles are perpendicular, then you get complementary angles. Okay, F says if 7 and 8 are complementary, then they add up to 90. So hopefully this one is starting to stick. If two angles are complementary, then they add up to 90, because that's what complementary angles are, right? That's the definition of complementary angles, which you can find right here. Two angles are complementary, then they have to add up to 90 because of that. Definition of complementary angles. And then the last one, 1 plus 2 equals BAR. That's just add two angles next to each other to get the big one. That's the angle addition postulate. Okay, let's move on to 10. And 10 actually is the same type of problem. So let's see here. First one says, if PV is perpendicular to VS, then PVQ and QVS are complementary. And that's actually just like this one. If two lines are perpendicular, then the angles in between are complementary. So it's the same exact reason as this one. Right there. Copy. Let's see if I can paste it. Of course, it didn't paste anywhere where I wanted it to. And everything moved. So let me just undo all that. All right, so I'll just write it. If the exterior sides of two adjacent angles, sorry about the lower in the background there, are perpendicular. I don't know if you can hear it or not, but it's driving me crazy. Complementary angles. Okay. There we go. There's the first one. Second one says if V is the midpoint of RS, then RV here equals VS there. Okay, so you got midpoint mentioned, so you probably are thinking it's got to be one of these midpoint things up here. It's either going to be the definition of midpoint or the theorem. The theorem involves half of the whole, but that wasn't here. This is just one half equals the other half. One part equals the other part. So that falls under definition. One part equals the other part. So that's going to be definition of midpoint. Let's see. C says RVP plus PVS equals 180, equals the whole angle. Or really, it's just two angles right next to each other equal the big angle. That's always angle addition postulate. In this case, it's actually the special case, but we don't need to write that. Let's see. The next one says RV plus VS equals RS. That's one part here plus one part right next to it equals the whole segment. So that's actually the segment addition postulate. Let's see. E. If RVQ, this angle, and the angle next to it are supplementary, then you can add them up to get 180. Well, here, let's come down here. Let's find the supplementary stuff. Here's one with supplementary. If two angles are supplementary, then they add up to 180, because that's the definition of supplementary angles. So that's what we're going to put here. Right? Same sort of thing. Definition of supplementary angles. Let's see, what's next? If PV is perpendicular to RS, then RVP is congruent to SVP, the angle next to it. Okay, so if perpendicular lines, then you get two congruent angles. So here's our perpendicular page. This is if perpendicular, then 90. That's not the same. If perpendicular, then congruent. Perpendicular lines form congruent adjacent angles. If you look at the picture, that's exactly what's going on here. Perpendicular lines do form two angles that are 90. They're congruent and they're adjacent. Okay. TS equals TS. Anytime something equals itself, that's reflexive. Oh, that is a terrible looking R, but oh well. You can kind of tell the marker is not working right here. Okay. Let's see. Next one. If VST and PVQ are complements of QVS, then VST and PVQ are the same. Okay. This one we don't really need the picture. If this one is a complement with that, whoop, so if these two are complements, then they should add up to 90. And if this one is also a complement with that, then these two should add up to 90. So if you add this to the other one, you get 90. If you add this to the other one, you get 90, which means these two should be the same, right? That's actually this little used reason way down here. If 1 and 3 are complements and 2 and 3 are complements, 1 and 2 are the same thing, are the same size. Complements of the same angle are congruent. Complements of the same angle are congruent. And then let's see, there's one more here. Okay, so the last one says if ST bisects, what was it, VSU? Yeah, VSU, this angle. So it cuts it right in half. Then TSU is half of the big angle. Okay, well, we have a bisector, so you should be thinking about the two bisector ones up here. Angle bisector theorem and angle bisector definition. And the definition says, let's see, how did this start? Started with if bisect. So if you have a bisector, the definition says you get two small congruent angles. That's different than this one. If you have a bisector, then one angle is half of the big angle. That's angle bisector theorem. That's what we want. Angle bisector theorem. Okay, so I hope that helps a little bit. And that's it.